Hello, this is my Project 9 lab. So basically what I'm going to do is first explain the code and the concept of the project and then show you the demonstration. So as you can see right here, this is the project I made, and I basically mounted an ultrasonic sensor on top of a servo motor. And what I did was I'm sweeping it 180 degrees in order to detect an object. Here in this case, I'm using just a coffee cup. And I also wired it up so that these lights detect outputs of 40 centimeters, 20 centimeters, and 10 centimeters. So depending on which output you see, a certain combination will light up. But I'll show you more about that in the code. So this is just the circuit overall. And as you can see, we have the wiring for the ultrasonic sensor, including the input, which is shooting out from here, and then the echo pin, which receives the readings backwards and puts them into the Arduino. So now I'm going to show you the code for the Arduino first. And up here, I'm basically just defining each of the pins. And then for this project, I used the servo library just so that it would stay a little bit cleaner. And I started my angle at 0 and servo position at 0. And then basically what I did was I defined all my pins. And then I start the angle at moving left to right. 180 is on the left side for the Arduino orientation, so I just started there. But basically what it does is it sweeps from left to right. So it's starting at 180, decreasing by 1 degree every time. And this is the code for the ultrasonic sensor. I got these specs online as far as the delay that needs to occur between each pulse. And then it basically takes the pulse in, and this is the conversion into centimeters. And then the motor's writing the angle. And then this is what I was talking about with the detection of 40 centimeters, 20 centimeters, and 10 centimeters. So it will digital write high. One light if it's only 40 centimeters away, 20 centimeters will light up 2 lights, and 10 centimeters will light up 3 lights. And greater than 40, it won't detect anything. And then this is the same thing, except going backwards the other 180 degrees. And then I'm serial printing this to the processing code. And so here's the processing code. I got some inspiration from the previous code that we had used as far as importing my data string. And then what it does is it reads the input angle and then converts that into a distance that can be used in processing for the x-axis, and it also converts the y into a distance from centimeters to basically the processing convention. And then it also prints a radar screen, kind of like a conventional radar, with it basically showing everything, and then it'll say target detected if something is detected within 40 centimeters. So this is only going to be ranging up to 40 centimeters. So next I'm going to show you the actual demonstration. Okay, so now I'm going to show you the demonstration. Before I run the processing, I'll just show you the output lights. So as it sweeps, one light lights up because that is not within the other ranges. And so I'll just bring this a little bit closer to show you how it lights up 2 and then to 3. So now it's out of range. And now I'm going to run the processing code to show you the actual graph display. So it's going to reset. And this is the radar sweeping scene. As you can see, it's about to detect it. As it detects it, it plots it on that angle. So now it's finishing and it's going back around, and it fills in a little bit more. But yeah. So now I'm going to show you just a different orientation, just to make sure that you guys can see full range. So there, it's really close to the sensor, so it's going to give that kind of longer sweeping motion. So as it comes back around, it's going to fill that in a little bit more. And yeah, now it's finished with its 2 sweeps. So this is the plot. But anyway, that is my project. I will attach the code so you can look at it closer. Thank you.